presentation, you'll be learning about light pollution, how it affects the night sky, and how it affects your observing, as well as some ways that you can help to monitor the amount of light pollution in your area for the overall scientific community. We all have experienced light pollution to some extent, so the most obvious source is sunlight. When the sun is out, our sky is very bright, and this means that we cannot see most objects in the sky. The moon will still be visible if it's in the sky, but other than that, the stars and planets are usually not visible when the sun is out, and that's because the sun is making the sky too bright to see these things. Other things that you experience similar to light pollution would be driving at night. If somebody's headlights are too bright, it makes it harder to see everything else. And to the point of what our presentation today is going to be about, for stargazing, light pollution can make very exciting stellar events hard to find or sometimes impossible to see. So we've all probably seen pictures from NASA or from stargazers of a perfectly clear night where every stellar object is visible. So the Milky Way galaxy, nebulas, and dim stars, as well as the bright stars and planets that we can normally see. But if you've gone out and you're in a city or somewhere that has a lot of lights, you probably did not see anything similar to these photos. On a clear night in the darkest parts of the world, you can expect to see several thousand stars, as well as most of the planets and the moon if it's out. However, if you are out in a clear night in a city, chances are you'll see anywhere between a couple dozen stars to maybe 100, a few of the brighter planets, and the moon will usually always be visible as long as it's up and you're having a clear night. Things like nebula and dim stars are very hard to see with light pollution, and things like aurora and faraway comets are almost impossible. Looking towards what the cause of light pollution is, it has to do with how light behaves. So light can travel as a particle, and what this means is it will continue in a straight line until it comes into contact with something. So what this means for us is when we put up a street light and it shines in every direction, the useful part of the light will shine down towards the ground, illuminating what we want to see. But there will also be a not useful part of the light output, which shines into the sky. And this light will shine forever in every direction until it comes into contact with something. So an easy way to see this is if there's clouds and these clouds pass over the source of light. We'll usually see the clouds glow in the sky, usually a dull orange color, and this is because of the color of most of our streetlights. However, even when there are not clouds in the sky, there's still enough particles to absorb this light and shine back to our eyes on the ground that we will see the sky glow a faint orange or whatever color our streetlights or other light sources tend to be. And this is what's known as light pollution. So even on the very clearest nights, when there's no clouds in the sky and there's not dust or anything like that, our skies will still shine a certain brightness, and this can oftentimes be bright enough to block out the dimmer stars, the dimmer planets, and the other events that we're hoping to see in our night sky. This background brightness that blocks out some of the dimmer objects in the sky is what we call light pollution, and this is specifically from man-made light sources. So we wouldn't exactly call sunlight light pollution, but it does act in the same way. Now that you have an idea of what light pollution is, we will go about an experiment on how to measure the light pollution in your area. So we're going to do two separate experiments, the bright measurement and the dark measurement. So our bright measurement is in an area which has a lot of light pollution, specifically a park next to the North Dakota State University campus. So there's a lot of sources of light pollution directly in the area, and it's within the larger city of Fargo, which creates a lot of light going into the sky. When we go to this place to measure, we can look up at the sky and see many of the brighter stars. So we were looking at Orion's belt and Orion, the constellation itself, as well as the constellation Leo. So after our group from the GradFi Club got to this location and set up our cameras, the first thing we did was wait a short amount of time so our eyes could adjust. Your eyes, they can adjust to the nighttime light, so if you've been outside for a long period of time, you notice you see things better and better. This works the same way with the sky. However, if you look at a bright source of light, even for a little bit, your eyes will adjust back to being used to bright sources of light. So it's very important to wait about 15 or 20 minutes after looking at a bright source of light, including your phone or some other screen, before you look up to the sky and expect to see things. So after waiting for our eyes to adjust, we gazed at the different constellations and we made notes of what stars we could see. So in both constellations, there are several very bright stars, especially Orion's belt has some of the brightest stars in the sky. But there are many, many dimmer stars that will be harder and harder to see depending on how bright your night sky actually is. So each group member was looking at these constellations and making notes of which stars they could see. And by comparing which stars we could see, we found that not everybody's eyes were the same. Some people had an easier time seeing the dimmer stars, and some people could still only see most of the bright stars with just a few of the dimmer stars visible. Our second location was the dark location. This location was located outside of Fargo city limits and far away from other sources of light. Again, we waited the time for our eyes to adjust and we got much darker pictures of the night sky. In some of these pictures, you can still see some of the light pollution from the city, but we were not directly looking into this light pollution as we were trying to observe these constellations. And just like with the light location, different members of our group were able to see different stars even after the light adjustment period had passed. That's just the way people are. We all see differently. So the way that you can help the scientific community is by basically taking a measure of the light pollution at your area. And the way that we can do that is by using this website, globeatnight.org. So when you come to this website, your screen will look something like this. We want to go to Report. Then it's going to ask you your observation date and time. So our observation date was March 11th, and the time was about 9 o'clock, so that is 21:00. Where did you make your observations? If you want to type in a zip code or an address, that would work too. Otherwise, you can use the map to zoom in on where you are. So finding the NDSU campus, and we were right about here, so just off the campus. You can also choose which constellation you were looking at. So we observed Leo and Orion, but I'm going to stick with Orion right now. Again, we were looking mostly for the belt and these other bright stars, but the dimmer stars are what's important. Also, what our sky conditions were like. So our night was very clear. Any comments about the sky? So if there were clouds, what did they look like? Was there glowing lights? Things like that. And then if you have a sky quality meter, those sorts of readings, or if you have a count, you can type that in too. But this is the main part of what we're trying to do. So when you're looking at the sky, try to remember which stars were visible. So looking at Orion, you can definitely see these stars here. So the belt, Rigel and Betelgeuse are the ankle and the shoulder. These other two stars here, this one, and this one, they're all quite bright. And then in the area, there are other bright stars. So this is stars you could probably be able to see. If you are deep in a very bright city or a very light polluted area, you may only be able to see Sirius, and that's the brightest star in the sky. If you can't see that one, your sky is very bright or very cloudy. But as we go towards dimmer and dimmer skies, you can see more and more stars. So what you want to do is go through this list and carefully look at what most closely aligns with the number of stars you could see. all the way up to magnitude 7, where you can pretty much see all of the possible stars visible to the naked eye. And even then, some people's eyes will never be able to see all of these stars. So as you get to darker areas, you probably will be more towards the right end of this spectrum, but you want to compare between these and pick the one that best characterizes how many stars you could see. So when I was observing, it is somewhere between these two here. And looking at the number of stars, I could see some of them here, but these stars up here were harder for me to see. I didn't really see them. So I believe magnitude 4 is what I am going to go with. And then you would click Submit Data, and that will send your data off for processing. Just like with our measurements from the light location, we logged our results on globetnight.org from the dark location, picking the picture that was most closely resembling what we could actually see in the sky that night. You can find future campaign dates and constellations at globetnight.org by following this link. So thank you for joining us. Hopefully you were able to get out and see the night sky and observe light pollution in your area. And if you did complete the activities, you're helping the scientific community and you're helping amateur stargazers find dark areas where they can observe these different events. So for that, we thank you, and we thank you for watching our presentation. We hope you enjoyed it and learned something along the way.